In this video, we'll just recall the lessons we have learned on the special vectors quality or the properties, that is its linearity and non-linearity. That means whether the vectors given, two or more vectors given, are collinear or they are non-collinear. The conditions are such that if some conditions supports for collinearity, if that is reverse or opposite, then it will be non-collinearity. So obviously, so the things we have learned, so just we will recap, and on that we will do some sums further to understand the condition. The conditions for recall condition. So first thing we will first see what is collinearity. Collinearity of vectors. So if I consider two vectors, let's say A and B, and let's say A is represented by A1I, B1J, C1K, and that B of B1I plus this is A2, A3, B2J plus B3K. These are the vectors A and B represent to the some sets of vectors. They are, you can say they are coplanar. This if A is saying they are not coplanar, they are, this is the vector that being represented by the component of the vectors as A1I, A2J and A3K, and that of, so if those vectors are to be collinear, that means I'm talking about A and B, these two vectors has to be collinear. The first condition that the ratio of their coefficient are to be equal. Okay, so this is for the collinearity. And if it is not, if not, then non-collinear, the opposite of that. So when we will do some example, if two vectors are given like that, so first we will try to make the coefficient, and if that coefficients are equal, then we can conclude that this A and B vectors or whatever the vectors being given are collinear. If not, straight we can say this is non-collinear. This is the condition that we have learned. Then after, if the vectors are collinear, we definitely can represent any other vector. And first thing is that for collinearity, the vectors has to be on same plane. So first thing is that the vectors are in same plane. So this is the condition of collinearity or non-collinearity, whatever you say. So for collinearity, the vector has to be in same line or parallel to each other. So we can say in a plane, let's say I'm talking about this board. If it is a plane, any two vectors, and I suppose the borderline is a vector, another, any two vectors is parallel to the other vectors lying on the same plane, or parallel to the other any other vectors in the same plane are collinear. So that condition may arise that they are lying on a same line. Those vectors, if I say A and B with respect to the C in the same plane, if it is parallel, the condition may arise that the A and B are lying on the same line, or A and B are in a different line. Okay, then also they are parallel to this. So condition says if two vectors which are to be in a coplane, which are to be in collinear, then in that plane in which A and B is lying must be parallel to any other vector. So in that case, that the vector which we are talking about may be in the same line or parallel to each other even. Okay, so then also they are parallel, because if they are in the same line, this AB individually are parallel to C, or if they are parallel to each other even, then A parallel to C and B parallel to C. So this condition, if two vectors lie in the same line or parallel line, they are called the collinear. If not, lying in the same plane, if not, they are parallel or lying in the same line, then these vectors are non-collinear. This is the physically we can define this. Now the conditions, the first condition, the ratios are to be same, then it will be linear, otherwise collinear. If it is collinear, then any other vector on the plane can be represented by these vectors involving scalars. This is the another condition where x plus y must be 0 for collinearity and x is equal to y is equal to 0 for non-collinearity. This condition is said to be linear dependent, and this condition is called linear independent. Okay, for linear independency, we can say that xa plus yb is equal to 0. Okay, where a and b are the vectors, x and a are the scalars. So these are the condition. This is the condition for linear dependency. This is our second condition. Third condition was that the cross product a cos b has to be 0 for collinearity or linearity, you can say, and that of a dot b has to be 0 for non-collinearity. Okay, that means two vectors. What is this? This is a b sin theta is equal to 0. Now it has to be 0 when sin theta is equal to 0, where theta is 0 for sin theta is equal to 0. That means this will be 0 when theta is 0. Means two vectors are making angle theta which is equal to 0, then cross product of this will be 0. That means if I do the cross product of this is, let's say a, this is b, a cross b if I want to do, and I have to get some resultant which will be following the right hand thumb rule, that must be on the vertical to this those vectors has to be 0. That means if theta is lying, these two vectors lying on each other, then only this will be 0. So the cross product for collinearity has to be 0 and dot product for non-collinearity has to be 0. This is nothing but AB cos theta is equal to 0. Theta is equal to 190. And that means two vectors, if it is at least lying, it is a specific condition lying with a 90 degree to each other, then cos 90 is equal to 0. That means two vectors are lying, so they are not collinear, they are non-collinear. This is the specific condition. And your for collinearity, the two vectors which collinear, they must be represented with this. That means a is equal to lambda b, where lambda is a non-zero scalar, non-zero scalar. Okay, so this is the for the condition of collinearity or linearity. If lambda is equal to 0, that means here it is said non-zero, then only that collinearity. If lambda is equal to 0, this is non-collinear. This is the condition. That means because a and b cannot be 0, because we are saying there is non-zero vectors, so only condition for which it can be 0 is lambda is equal to 0. So for any case, when two vectors is represented in such a way, lambda is equal to b cannot be, because this will be 0. That means out of the two vectors, if I represent any two vectors, any other vectors with the help of this vectors a and b, then this vector, either of these two vectors, either of the two scalar could be 0 or this could be 0. That means lambda could be 0. So lambda could be 0. That means we can say, so if examples arises in such a way, then we can put this condition that lambda should be 0 for non coplanar. So this condition also are the condition for non-collinearity. So these are the conditions. Now specifically you have learned collinearity and non-collinearity. Physically you understood what is collinear and non-collinear. Now we'll do some examples on this collinearity. So it says example 1, it says if A is 2 by 3, that means 2 by 3 when it is being said as a coordinate in 2xy coordinate, if any point is represented is 2 by 3, but in case of vectors this could be represented as the vector would be represented as J. There will be two component, one component of x direction, other component. So means this point, if it is represented with the 2, 3 coordinate vector, that is represented by this OP. Let's say I am taking that OP position vector is represented by 2y plus 3j. So this is the change in the representation. If it is a point, this is 2, 3. If it is a vector, then it has to be like that. So this is a vector. So vector A is represented by this, vector B is represented by 4, 6, and that of vector C is by 6, 12. So now you have to prove whether it is collinear or linear. So what you understood, A is nothing but 2i plus 3j, B is nothing but 4i plus 6j, and C is equal to 6i plus 12j. Now if these three vectors has to be collinear, so we can take 1 by 2 pairs together, because if I can prove A and B is collinear, then after B by C is collinear, then definitely all three are collinear, that we can prove. So 1 by 2 we will take 2 together. So if I consider for this, so what is that, the ratio of the coefficient should be same. So if I take 2 by 4, it is equal to half. Now if I take this 2, 3 by 6, that is equal to half. So these coefficients of I and J are same, so these are co-linear. These two. Now talking about this B and C, this by this is equal to 4 by 6, that is equal to 2 by 3. Now 6 by 12, it is what, half. So these are not equal, so these are non-collinear. I am taking the abbreviation. This is C for collinear, non-collinear. Now talk about A and C together, then definitely it should not be collinear, because A and B are collinear, so these are in same thing. B and C, if it is non-collinear, so B is like A. If it is B unlike C, so A should be unlike C. So let me prove. So if I take A and C together, so 2 by 6 is equal to 1 by 3. Now 3 by 12 is equal to 1 by 4. So these are not equal. So A and C, these are non-collinear. Okay, so that can be proved. Let me take another example. Yeah, in this case it is example number 2, and the vector is A represented by, this time it is Cartesian representation, because there are three components are coming, x, y and z. So now this vectors are this, so we can represent this as 3i plus 5j plus 7k, and b is 6i plus 10j plus 14k. Now this has to be proved whether collinear or linear. So now if I take the ratio 3 by 6 is equal to half, if I take 5 by 10 is equal to half, if I take 7 by 14, that is equal to half. That means all these ratios are same, so A and B are collinear. That can be proved. Okay. So let me take some more example. Okay, fine. Now example 3. It says if the points, it says if the points a 60i plus 3j, this is one point, another point B is 40i minus 8j, and C ai minus 52j are collinear. Okay, then find A. Okay, so this is the task. This is already said this is a collinear. So we know if 3 points A, B or C collinear, this time it is collinear. That means if I take, it is two-dimensional. So in two-dimensional plane, this is y, this is x. Let's say A, B, C are collinear. Then we have to find the unknowns. Means A have to find, and here only A is unknown. We can find. So if these are collinear, that means the three line if I join, that should be in the same line. So that means we can say the slope of the line if I join A and B is same as if I join the any 2 point, means B and C if I join, or A and C if I join. That case the line it will form, it will be in the collinear. Now 2 point, if I want to make one vector representation of anything, so 2 point if I join, then this together will be a vector, not a single point will represent a vector. Now again, if it is A, this is B, then 2 points if I join, that will be a vector. So these vectors will be achieved by joining two lines. Now in that case, A and B, the slope will be same. So for that case, this is the x component, this is y component. So in that case, you want to assume graphically, this is, if it is A, 60, 3, this is the coordinate. For B it is 40, minus 8, and C is A, minus 52. Now this if I drop, and accordingly what is the thing if I get joined this, so this is the x component of this point and y component. Okay, and this is the x component of this is y component. Now if I join this, what would be the slope? What would be my slope then? This would be, if I want to get this slope and accordingly get this slope has to be same, theta. Okay, now how will I get that tan theta of this? It will be this part is equal to what? This minus total this minus this. So what is that? If I take this is the y part, y minus of minus 8, that means minus 8. This will be the y part, this part, and x part will be the total, this one, this is 40, and minus this point, because if I take this is 40, whereas this has to be taken because this is higher. So this point will be, anyhow I am keeping the orientation same. So this is 40 minus this one, if I take the lesser one, so this will be the same. This is the coordinate. And for other point, this will be, for this case it is will be y minus 52 minus of minus 8. This will be the case because this will be the lesser one, this is the higher one. So this, sorry, did wrong, minus this case, this is higher, so minus of minus 52, and that of this height is subtracted. This will be the A will be higher, A, minus this will be 40. I have taken the same orientation, 40 or 60 minus 40 this case. This will be, if I take the same orientation, 40 will be higher. The 40 minus 60 I am doing here. I am keeping the same orientation. 40 minus 60, in that case also A assumed to be high, so A minus 40. Okay, so this has to be same. These two, whatever way I have taken, I have not taken in the real condition. I have not plotted in the real condition. So whatever the result come, thing is that you have to take in same orientation. You have to this case, if I take the reverse, and that case the reverse, that result will be different. But I have taken this is in a whatever with the situation I have taken in the same order, so it will give the right answer. So it is 11 upon minus 20 here, and this is equal to 52 minus 8, that is equal to 44, I suppose. Yeah, 44 divided by A minus 40. So from there, if I calculate, it will be 11 into A minus 40, that is equal to 44 into 20 divided by 11, and that will be minus 4, that will be minus 80. So A is equal to minus 40, because A will be that correct. So your value of A will be that. So there I have physically I have represented the slope, because if it is in the same line, so the slope of the line joining by these 2 points has to be the same with this. Okay, now this is same as collinearity. Now this can be done with help of, if this is the 2 terminal point of vector, that means if I want to get BA vector, so that is equal to B minus A, basically B vector. So what is that? B is equal to 40i minus 8j minus 60i minus 3j. Now if it is so, 20i and this is 11j, this is the vector BA. And similarly, if I join C and B, so CB vector is equal to C vector minus B vector, that gives C is what? AI minus 52j, and then minus 40i plus 8j. So if I do it, it will be A minus 40i minus 44j. Now these 2 vectors has to be collinear. So what is the condition for collinearity? The coefficient of I, the ratio of coefficient of I must be same as the coefficient of J, because all coefficient has to be equal, then only it is to be proved that collinear. With the same thing, if I go, so I will give you the same result. So this is 4 into this, so ultimately A minus 40 will give you minus 80. So that from there also, so we have did in same way. Physically we presented the point and taken the slope, and with the concept that the collinearity arrive when I will join 2 point, will give you 1 vector, and if consequently if I get 2 vectors, which is a linear vector, to be in same line, then their coefficient of the respective vectors, that means the coefficient, the scalar ratio, or the coefficient of the respective vectors has to be same. On that concept I solved this problem. So this is for now. The next video I'll move on to some more problem on this to understand better, maybe 2-3 problem. Then after I will go to the theory of coplanarity and non-coplanarity. This is the just the same similar topic to the this collinear and non-collinear topic. Okay, but that condition differs, as because that time we will talk about the plane, and this time we will talk about a line. So thank you for now. Good night.